All right, so the last one is from the heat transfer and calorimetry homework, and it is part D, I believe, which, if I could just start by saying, is a pretty bogus problem to begin with. It's algebra is all that it is, but algebra has no place in chemistry, so it's just kind of a dumb problem in the first place. But nevertheless, we must learn how to do it. So, all you really have to know is after answering the first three parts of this question, we basically end up with a thing that Professor White did an example of in his lecture on Monday. And all that is Q of one thing is going to equal Q of something else. I'm going to zoom in a little. All right, so Q of one thing equals Q of something else. So, for example, he did a piece of metal in a cup of water, right? And after you leave the metal in there for so long, eventually the metal's heat is going to go into the water, and then the water's cold is going to go into the metal. So in the end, after a long enough time period has passed, the temperature of the metal and the temperature of the water are going to be more or less the same. And that's all this is right here. And that's all it's asking for in part D of this question. It basically just says that after a long enough time, the heat or the temperature level of the aluminum is going to be the same as the temperature of the iron. At least I got aluminum and iron. I don't know if the elements you got were different, but that's all it's saying. So if you remember from the homework you just did, which would be the specific heat calculations, Q is equal to S times M times the change in T, right? So if we know Q is this, well then we can just substitute this whole thing right here, these three factors, in for Q, right? Does that make sense? So if we have Q of aluminum and Q of Fe, then we can just substitute the S times M times T of aluminum is equal to the S times the M times the T for iron, right? Doesn't that make sense? Because this is just Q right here, given by this equation. And since we know these two Q's are the same, we can just substitute these two in. All right? So now if you go to the very top of the problem, if you scroll all the way at the top, it's going to give you some information that we need to solve this problem. So for my example, it says that the grams for aluminum is going to be 25.9. All right, so we got our M. It says the temperature is going to be 50.9 for aluminum. All right, so we're going to make that X minus 50.9, and I'll tell you about that in just a second. And then finally, if you scroll back to the bottom of part D, it's going to give us the S. It says the specific heat, which is S, the specific heat for Al is 0.901. 0.901. All right, so now we got our S, which it gives us to us at the bottom at part D. We got our mass, which it gives us to at the top. And we got part of our temperature. Now, the reason it's part of our temperature is because back at the very beginning of the problem, it says that 50.9 degrees Celsius, which is the temperature for aluminum, that's the temperature at the beginning. But part D is asking us for the temperature at the end, when both of them are the same. So in order to find that out, we just have to take the temperature final, which we don't know, minus the temperature initial, which we do know is 50.9. And I just made this temperature final in X because it's easier for me to do algebra that way. All right, so hopefully that makes sense. We got our S, we got our M, and we got our change in temperature, which is represented by this X minus 50.9, because this 50.9 was the temperature which we started with. All right, so that's the aluminum side. Now we have to do the exact same thing for the iron side. All right, now if you go to the bottom at part D, it says that the specific heat, the S for iron, is 0.449. All right, 0.449. Then if we go to the top, it says that our grams are 25.9, again, just like aluminum. And then it says our temperature is going to be 59.2 at the beginning. All right, 59.2 is what we start with. But once again, we're looking for the final, not what we started with. So to do that, you just do T final, T's for temperature, the final temperature minus the initial temperature. So that's just the same as X minus 59.2. All right, so this is our algebra problem that we set up, and I'm not going to work through it, but it's just, you know, simple algebra. You multiply these two together first, and then you multiply that. Actually, you know what? Let's just work it out. All right, so we got 0.901 times 25.9 times X minus 50.9 is equal to 0.449 times 25.9 times X minus 59.2. All right, so I'm just double checking if this is what I had the first time I took this problem. Yep, all right, sweet. Now all you have to do is multiply everything together just like you would for a normal math problem. So I'm going to do these two first, 0.901 times 25.9. All right, so that's going to give me 23.3 times this X minus 50.9. I'm going to do the same thing on the right side. I'm going to do the 0.449 times 25.9. All right. And then one more thing. Sorry, I forgot to mention this. This 0.449, it's supposed to be negative. Now, to be honest, I'm not okay. So the reason it's negative is basically because the heat is flowing out from the iron. Therefore, the iron loses the heat, whereas the aluminum is positive because it is gaining the heat that the iron loses. You have to read that in the question. But for now, just trust me that it's negative. If you don't put that negative sign there, your algebra is going to be off. So I'm sorry I didn't mention that in the beginning, but this iron is negative. So make sure you do that. So when we multiply those together, we're going to get negative 11.6 times X minus 59.2. And then you're going to do the distribution just like you would, in algebra. So this is going to become 23.3x minus 23.3 times 50.9 is going to be 1185.9. We'll just do 1185 to round up. All right, so that's going to be on the left side. Then on the right side, you're going to get negative 11.6x. All right, and then negative 11.6 times negative 59.2 is going to be 686.7. And that's going to be positive because it's a negative times a negative. All right. Then you're just going to add everything to the side that you want it on. So I'm going to take this 11.6 and add it to this side. That's going to make it 34.9x, because these are both x's, right? You combine like terms, just like in algebra. And then you're going to add the 1185 to the side with the 686.7. So that's going to give you 1,871.7, and then you just divide both sides by 34.9, and you get 53.6, which will be your final answer, and that's going to be the answer for both. So again, this problem, I am almost certain it will not show up on the exam. It's really just a lot of annoying algebra. But make sure you don't forget that negative sign. I'm again sorry for not mentioning that before. and just solve out the algebra like you would in a normal math class, and this is what you get. So